Now we're going to move into Chapter 2, Section 3, The Earth Takes Shape. Now understand there are a lot of different beliefs on how the Earth actually took shape. Scientific, religions, a lot of different people, cultures have different thoughts on this. But being a science class, we're going to talk about how most in the science field agree this happened. So we'll start off with the solid Earth forms. We'll begin our discussion with the early stages. Now remember back to Section 2 where we talked about how planetesimals formed, from starting with dust particles that began having some gravitational pull towards each other, big collisions, these larger and larger shapes, being created when these things run into each other. Okay, so as these, planetesimals get bigger and continue to collide into each other, and again, I talked about the snowball analogy of taking two and ramming them together, losing some particles but gaining a bigger one overall. Those first initial shapes are going to be very odd, maybe like a potato, if you will. Okay, but again, as it increases in size, it's going to be, obtaining more gravity, which is going to allow it to attract more and more material. And with these colliding plasmatismals, the more that this happens, again, the more heat that's going to be generated. Now, because of all this tremendous heat, the center actually couldn't cool fast enough. So think about the outer edge as it starts to cool, kind of creates a barrier, almost like an insulator, keeping that center in that liquid form. Now, due to this cooling process, this created layers in the Earth. Okay, initially, as rocks melted, the more dense materials would sink, which we've talked about many times throughout the year in 8th grade science. Again, the more dense, the more it's going to sink. Think of something in the water. Okay, a bowling ball, because of its density, is going to sink to the bottom if you throw it in, where a basketball, even though they're roughly close to the same size, is going to float on top. That's due to density. This separation then is going to create these layers that we see today. Now we want to have a little discussion on the Earth's interior. The three layers of the Earth's structure are definitely going to be reviewed from previous science classes you had in elementary school or earlier in middle school. They are the core, the mantle, and the crust. In the core is where those dense particles sank to, and it's where you'll find the heaviest material. The mantle, which is the middle layer, is going to have rock that is more dense than the crust. The final layer, or the outer layer, is called the crust. This is a relatively thin layer in comparison to the other two that covers the entire Earth. This now leads us to the development of the Earth's atmosphere. The original atmosphere of the Earth is believed to be very steamy, full of water vapor and carbon dioxide. The materials that made up this atmosphere came from meteorites and volcanic eruptions. Then we transitioned into a second phase of the atmosphere. Now in the second atmosphere, the Earth is beginning to cool. Some of the things that are crashing into the surface are starting to have a little bit less effect. There are volcanoes everywhere though, which are producing things like chlorine, nitrogen, sulfur, and large amounts of carbon dioxide. The next transition is to what we currently call our atmosphere. UV radiation from the sun began to break down molecules and change and develop the atmosphere. Pieces of these broken molecules then began to fall into the ocean. These pieces then develop into what scientists call the primordial soup, which ultimately led to the beginning of plants. These new developed plants then use sunlight to produce oxygen. In today's atmosphere, we now find it's composed of 78% nitrogen, 20% oxygen, 1% argon, and 1% others. This is the end of the Section 3 notes. Make sure you should have all 3 sections now for Chapter 2. Make sure you hang on to them and use them to study for your test. Good luck.